Earth has been a stage for life for more than 3.8 billion years. And yet, over 99% of all species that ever lived are gone, wiped out, vanished. Entire ecosystems erased. You've probably heard of the dinosaurs' demise 66 million years ago, thanks to an asteroid strike near today's Yucatan Peninsula. But what if I told you that wasn't the first, or the worst? Scientists officially recognize 5 major mass extinction events. The Ordovician Silurian extinction, approximately 444 million years ago. The late Devonian extinction, approximately 375 million years ago. The Permian Triassic extinction, approximately 252 million years ago, aka the Great Dying, when over 90% of species disappeared. The Triassic-Jurassic extinction, approximately 201 million years ago. The Cretaceous Paleogene extinction, approximately 66 million years ago. But here's the kicker. There are at least 18 other smaller but still catastrophic events scattered throughout Earth's history. Some took millions of years, others were sudden, almost overnight by geological standards. Question is, why do these disasters seem to come in cycles? Random chaos, or something hiding in plain sight? Mass extinctions are like punctuation marks in the book of life, abrupt, dramatic, and leaving behind a mystery in every chapter. But what triggers them? Volcanoes, asteroids, supernovae, or something even bigger, a hidden pattern? Let's start with what science says. For decades, researchers believed these extinction-level events were largely random, caused by independent catastrophes. Massive volcanic eruptions releasing toxic gases and triggering runaway climate change. Asteroid impacts, like the Chicxulub strike, which snuffed out the dinosaurs. Climate shifts due to continental drift, glaciation, or methane release. But then, a strange observation emerged. Many of these cataclysms seemed to cluster at regular intervals. Studies in the 1980s suggested a cycle of roughly 26 million years between major extinction spikes. Later analyses stretched that to somewhere between 26 and 30 million years. Coincidence, or a cosmic clock ticking away in the background? This wasn't just about Earth. Some geologists noted that impact craters on Earth and the Moon appeared in groups, hinting that the inner solar system itself goes through periods of heavy bombardment. If true, that suggests something out there is periodically shaking loose a storm of comets and asteroids, sending them crashing inward like celestial billiard balls. Here's where things get interesting. The timing of these cycles roughly aligns with the Big Five and many of the smaller extinction pulses. That's a hard pattern to ignore. It's like finding fingerprints at every crime scene. They may not convict someone outright, but they point to a suspect. Could there be an unseen player pulling the strings? A gravitational puppet master lurking in the shadows? This is where the Nemesis hypothesis enters the stage, a theory that sounds like science fiction, but was seriously proposed by astronomers in 1984. They suggested that our sun might have a dark companion star, orbiting far beyond Pluto, making an enormous loop around the solar system every 26 million years. Every time Nemesis swings by, its gravity disturbs the Oort Cloud, a vast halo of icy bodies at the edge of the solar system, sending a death rain of comets toward the inner planets. If that's true, it would explain why life on Earth suffers catastrophic resets with unnerving regularity. But before we dive into Nemesis, let's consider what this means. If extinctions are cyclic, they're predictable. If they're predictable, something out there is causing them. And if that something is Nemesis, we're living in a system with 2 stars, one of them hiding in plain sight. So where is the origin of the Nemesis theory, and why astronomers once believed it was real, and why some still quietly do? In the early 80s, paleontologists David Raup and Jack Sepkoski are deep in fossil records, crunching data that spans hundreds of millions of years, discovered what will send shockwaves through the scientific world. Mass extinctions don't happen randomly, they follow a pattern. Every 26 million years, give or take, something wipes out a huge swath of Earth's biodiversity. This wasn't a subtle pattern either. It showed up again and again, like an ominous drumbeat echoing through time. Raup and Sepkoski presented their findings in 1984, and the astronomical community took notice. If extinctions happen on a schedule, the cause has to be external and recurrent. Enter the Nemesis hypothesis. The idea was audacious. Maybe our sun has a distant, dim companion star. A small, cold red dwarf or even a brown dwarf, too faint to see easily, lurking far beyond Pluto in the deep freeze of interstellar space. This companion, dubbed Nemesis after the Greek goddess of retribution, would orbit the sun at an incredible distance, perhaps 1.5 light-years away at its furthest point. Its orbit would be elongated and slow, taking tens of millions of years to complete a single revolution. Most of the time, Nemesis would slumber in the darkness, harmless. But every time it swoops in near the Oort Cloud, a vast shell of icy debris encasing the solar system, its gravity would act like a cosmic cue-stick, knocking countless comets out of their stable positions and sending them hurtling inward. The timing fits eerily well. The dinosaur-killing asteroid, about 66 million years ago, that's roughly 2 Nemesis cycles back. The Permian Triassic extinction, the worst die-off in Earth's history, 252 million years ago, that's about 9 or 10 cycles. Raup and Sepkoski's 26 million year pulse suddenly didn't seem like coincidence. NASA and other agencies even launched infrared surveys in the 1980s and 1990s to hunt for Nemesis. They didn't find it. But here's the kicker. Even today, we haven't fully mapped the outer solar system. Objects like Sedna and other distant bodies were only discovered in the 21st century. The frontier is vast and largely unexplored, so the Nemesis hypothesis hasn't been proven. But it also hasn't been fully buried. It lingers, waiting in the shadows, like the star it proposes. Could there be any evidence suggest the existence of this enigma called Nemesis? If Nemesis really exists, its legacy wouldn't just be written in Earth's fossil record. It would be etched across the solar system. Think about it. If a rogue companion star stirs up the Oort Cloud every 26 million years, Earth wouldn't be the only target. The entire neighborhood would feel the tremors. So what does the solar system reveal if we start looking at it through this lens? First, consider impact craters. Earth has some, but erosion, plate tectonics, and oceans erase evidence over millions of years. The moon, though? It's like a dusty time capsule. Its surface has been geologically dead for billions of years, preserving scars from every major collision. When scientists mapped lunar craters, they noticed something weird. Impact clusters, periods when the moon got pummeled more than usual. Guess what? Those clusters line up suspiciously well with Raup and Sepkoski's extinction cycle. But it doesn't stop there. Look at Mars, home to the massive Hellas Basin and the northern lowlands, which some theorize were carved out by titanic impacts. Jupiter and Saturn? They act like giant cosmic goalkeepers, sweeping up comets before they reach the inner planets. Remember Comet Shoemaker-Levy 9 slamming into Jupiter in 1994? That was just one fragment. Now imagine dozens or hundreds of comets unleashed in a Nemesis-induced storm. Jupiter and Saturn would take the brunt, leaving behind atmospheric scars. Scars that would fade within decades. Even Earth's oceans hold mysteries. Vast impact craters are rare on land, but ocean impacts? They disappear quickly, erased by tectonic churn. The Chicxulub crater, the dinosaur killer, survived only because it hit shallow seas. If a Nemesis-triggered comet slammed into the deep Pacific 100 million years ago, its signature might now be buried miles below the seafloor, or recycled into the mantle. Could the several trenches on the ocean floors be the ghost of a catastrophic strikes? It's a radical thought, but not impossible. But if the evidence is so suggestive, why is Nemesis still unconfirmed? If Nemesis is real, and if it has been wreaking havoc on Earth every 26 million years, then why haven't we seen it? Surely a star orbiting the sun, even from a distance, would be obvious by now, right? Well, not so fast. Nemesis, according to most hypotheses, wouldn't be a blazing sun. It would likely be a brown dwarf, a failed star that never ignited bright hydrogen fusion. These objects emit so little light that they're practically invisible in optical wavelengths. If Nemesis is out there, it's not a second sun shining in the night sky. It's a faint ember cloaked in darkness. To find it, we'd need infrared eyes, like those on NASA's WISE, Wide Field Infrared Survey Explorer, or the James Webb Space Telescope. Here's the kicker. Even with infrared surveys, the outer solar system is a mind-bogglingly big place. If Nemesis exists, it could be tens of thousands of astronomical units away, so far that its orbit takes millions of years to complete. That means, from our perspective, it would barely move against the backdrop of stars, making it extremely hard to distinguish from background objects. In short, the search is like looking for a brown marble in a field of black sand, in the dark. Here's a mindbender. If Nemesis is real and still lurking, it's out there right now, circling in the cosmic dark, waiting for its next pass through the Oort Cloud. Maybe it's already on the move, stirring up icy missiles that will fall inward in the far future. Or maybe its last visit was its final bow, and it's drifting away forever. We simply don't know. But here's the real question: what would happen if we actually found Nemesis tomorrow? What would that mean for science and for humanity's sense of security? If Nemesis is real, every extinction event in Earth's history takes on a new dimension. Those mysterious 26 million year cycles, no longer a coincidence. The asteroid that wiped out the dinosaurs, may be just one of many comet bombs Nemesis has been loading into the solar system for billions of years. Suddenly, the story of life on Earth looks less like random bad luck and more like a cosmic pattern, almost like clockwork. That's both fascinating and terrifying. But here's the deeper, more existential twist. The Nemesis discovery would remind us that Earth's habitability is not permanent. Life's biggest threats don't just come from within, from climate change or pandemics, but from the cold, indifferent machinery of the universe. Knowing Nemesis exists means accepting that life on Earth has always been playing a game of cosmic Russian roulette. If Nemesis exists, it's playing the ultimate game of hide and seek, and so far, it's winning. But here's the thing, we're no longer blind. For the first time in human history, our technology is powerful enough to scour the darkness for this hypothetical killer star. And the search isn't just about curiosity, it's about survival. If we find Nemesis, how would the world react? Would people cheer because we've solved a cosmic mystery, or spiral into panic, knowing that extinction might be on a countdown clock? The idea that our star has a murderous twin orbiting silently in the dark, that every 26 million years it plunges through the Oort Cloud, hurling icy missiles toward Earth. That realization would make climate change, wars, and politics feel like background noise compared to the ticking of a cosmic time bomb. Then comes existential dread, because the question everyone would ask isn't does it exist, but when will it strike? If scientists announce that Nemesis won't disturb the Oort Cloud for another 10 million years, people might shrug and move on. But if they say it's due in 5 million years, or worse, 500,000, that changes everything. Whole civilizations rise and fall in that time, sure, but suddenly humanity has a deadline. Nemesis might have been painted as a villain, a shadowy assassin lurking at the edge of the solar system, striking every 26 million years. But what if this so-called dark star is more than a harbinger of doom? What if Nemesis is the very reason we're here, and the reason we might survive the next billion years? The next reboot could be on our terms, if we play it right. The knowledge that Nemesis exists would change everything about our future. Suddenly, space isn't a luxury or an ego project. It's survival strategy. It means funding asteroid defense systems, building interstellar drives, mining the outer solar system for resources, and, yes, finally getting humans to Mars and beyond. Nemesis could be the kick we need to evolve technologically before nature forces another reset. Just as fire and electricity propelled us into new eras, Nemesis might propel us into the stars. Because when you know the universe has a built-in extinction timer, procrastination stops being an option. But here's the twist. Even if we never find Nemesis, if it turns out to be myth, a cosmic ghost story, it still matters. Because the act of searching, the act of preparing for the worst, forces us to imagine something bigger than ourselves. It forces humanity to confront its vulnerability and its potential. Maybe Nemesis isn't out there. Maybe extinction comes from an asteroid, a gamma-ray burst, or even our own hubris. Doesn't matter. The real Nemesis we face is complacency. If a hypothetical dark star is what it takes to wake us up, then let Nemesis live on in our imagination, because imagination is what builds rockets, shields planets, and carries life from one world to the next. So here's the question I'll leave you with. If Nemesis is real, and its next pass will shake the Oort Cloud in, say, 10 million years, would you sleep better, knowing you'll never see it? Or would you feel responsible for starting the work that ensures life, human life, outlasts the next cosmic purge? This is AstroTheatis. Stay curious, and keep looking up.